Unit 2, Lesson 7, Creating Double Number Line Diagrams. Let's draw double number lines like a pro. In other words, let's make you guys some rock stars. By the end of this lesson, I want you to be able to create a double number line diagram and correctly place and label tick marks to represent equivalent ratios. I also want you to be able to tell me what the word per means. Okay, so our warm-up activity is ordering on a number line. Please pause the video and take a couple minutes to locate and label the following numbers on the number line and answer based on where you placed your numbers. Locate and label 4 or more fractions or decimals that could be on that number line. Okay, now that you've paused for a little while and you've come back, let's think about how we're going to break this number line down. We know that it starts at 0 and it goes all the way up to 2. So if we thought about this, halfway would be what number? That number would be 1, wouldn't it? Doesn't 1 help us kind of figure out where we can put the rest? Because if we know where 1 is, that means that we know that halfway between that halfway point is going to be 1/2. So there's our first fraction put up there. 1/4. Is that bigger or smaller than 1/2? Well, if we think about dividing something up into halves, or in other words, 2 pieces, think about a pizza. You split it in half. That's only two pieces that you have to share. Now think about 1/4. That means that you have to cut it into 4 pieces. Which one do you get a bigger slice of the pizza? Well, 1/2. So that means 1/4 is smaller. So that means, and if we think about it, 1/2 compared to 1/4, 1/4 is half of 1/4. Half. So that means we should put that in the middle between 0 and 1/2. So now we got 2 of those done. Alright, so we got 1 3/4, 1 5/10, 1 75/100. 1 5/10. Let's start there because that sounds like it might be a benchmark number. 1 5/10. What is that known as a fraction? 1 with 5/10. Can't we simplify that? 5/10 would become 1/2. So that's really 1 1/2. If we know 1 is straight in the middle between 0 and 2, we just need to find that halfway point between 1 and 2 to put the 1 5/10. Okay, so now we have that one on there. So now we have 1 3/4, 1 75/100. 1 75/100. So that's 1 with 75/100. Won't 25 go into both of those? So if we take 75 divided by 25, that's going to give me that's going to give me 3. Because I know if I have 3/4 and I divide by 1/4, or put them into groups of 1/4, that gives me 3 groups. And I know that 100 is divisible by 25. And 100 divided by 25 is 4. Wait a minute. We've already got 1 3/4 there. 1 75/100 and 1 3/4 are the same. So is that bigger or smaller than 1 5/10? Well, 1 and 75 hundredths is going to be bigger because if we look at the tens place, 7's bigger than 5, right? Or if I have $1.50 and $1.75, which one's bigger? Well, $1.75. And isn't that going to be halfway in between 1.5 and 2? And since we already know that 1 3/4 is the same as 1 and 75 hundredths, we can label both of those. Okay, so that's for question 1. We've now used all of those. We need to place 4 more fractions or decimals on the number line. Well, what's another way to say 1/4? 0.25. Because if you have a fourth of a dollar, you have 25 cents. What do you have if you have a half of a dollar? You have 5/10. I know you guys said you had 50 cents, but if we're just looking at it as a decimal, is that 0 holding the place for anything else? No, so I don't need to say that's 50 hundredths when I can just say that it's 5/10. What would be another way to say 1? Well, we've divided into fourths so far, or you can even think of it as halves. That'd be 2 halves or 4 fourths. Okay, let's go ahead and place another one on here. What would be halfway in between 1/2 and 1? So if we know that 1/4 is 25 hundredths, 1/2 is 5/10, that would be 75 hundredths. So we had 25 hundredths plus 25 hundredths plus 25 hundredths. All right, for our next activity, it's called Just a Little Green. What are double number lines? How can we use them to represent problems involving equivalent ratios? So remember that we're going to investigate the double number lines a little bit more deeply when I ask those questions. Okay, so when we look at this, question 1 asks us to label 4 tick marks shown. They've already labeled both of the number lines for us. They said that the blue water is going to be measured in milliliters and that the yellow water is also going to be measured in milliliters. So let's make this as simple as possible. When we look at this, we have 0 and we have 5 and we have 4 tick marks in between. So what can we label the first one? 1, then a 2, then a 3, then a 4, and we're up to 5 now. Okay, so for the second one here, we need to draw those tick marks on the second number line. Remember, they should be drawn vertically with the ones right above them. All right. They're making this one a little bit harder for us, though, aren't they? Because they didn't tell us what numbers to put on those ticks. So let's think about this. We started at 5 here, and we went all the way back to 1. So we took 5 times what number to get 1? I don't know, Mr. Reeser, but I know that 5 divided by 5 is 1. So, in other words, what you just told me is that you're taking 5 times 1/5. So if we're taking the 5 times 1/5, doesn't that mean that we should take 15 times 1/5? And what's 1/5 of 15? Or 15 divided by 3? I'm sorry, I said that wrong. I gave you the answer. 15 divided by 5. It's 3. So now we have 1 to 3. 1 milliliter of blue to 3 milliliters of yellow. We're going to double that because we took 1 times 2 to get 2. So what's 3 times 2? 6. Go back to our original ratio of 1 to 3. So we're going to take 1 times 3 to get 3, and 3 times 3 to get 9. Going back to our original ratio of 1 to 3, 1 milliliter of blue to 3 milliliters of yellow. What do we take 1 times to get 4? 1 times 4. And anything I do to one, I have to do to the other. So now that we took the top 1 times 4, we have to take the bottom 1 times 4. And 3 times 3 is 12. All right, question number 3. How much yellow water should we use for 1 milliliter of blue water? Circle where you can see this on the double number line. Okay, so we're looking for 1 milliliter of blue water. So that means we're looking at the top number line. Let's find the number 1. Oh, there it is. And how many milliliters of yellow do we need? 3 milliliters. Okay. How much yellow water should be used for 11 milliliters of blue water? Oh, I don't have that on here. How could we figure that out? Yeah, if you're thinking, well, we've always just taken our original ratio times whatever number of batches we need. You're right. So let's take 11 times, and when we look at the number 1 here, because that's 1 milliliter of blue water. So we're taking 11 times 1 to get 11 milliliters of blue water. And anything I do to one number, I have to do to the other. So that means take 3 times 11. That means that we're going to have 33 milliliters of yellow water. Question number 5. How much yellow water should be used for 8 milliliters of blue water? Well, if you wanted to, you could go 6, 7, 8, 9, and then fill that out. Or again, come back to our original ratio of 1 milliliter of blue water to 3 milliliters of yellow water. We're taking 8. We need 8 of those for the blue water, so that's 8 times 1. So what's 8 times 3? 24 milliliters. Why is it useful to know how much yellow water should be used with 1 milliliter of blue water? Because we want to know the equivalent ratio. So that way we get the same color every single time. Okay, now we're going to talk about per. Have you ever walked into a store and seen that they're having a sale on your favorite sweater, t-shirt, whatever? And let's say that it's $25 for 2 shirts. Do you really have to buy 2 shirts? No. So don't you want to know how much it is per each shirt? The word per means for each. For example, if the price is $5 per ticket, that means you will pay $5 for each ticket. Buying 4 tickets would cost $20 because 4 times 5 equals 20. Our next activity is art paste on a double number line. Okay, so I already started following the instructions to draw a double number line diagram representing this art paste. So I drew my 2 parallel lines. I labeled the first line pints of water and the second line cups of flour. Then I drew 6 equally spaced tick marks in where it says at least 6. If you notice, I did more because it says to put in 0, 1, 2, 3, 4, 5. For those of you that didn't catch that the sixth one that you put on there was actually 0. And then along the flour line, I did the same thing. I did 0, 1, 2, 3, 4, 5. Take a minute, if you have the time, if you're working with someone else, compare that to your partner's, or compare it to mine. If needed, change your diagram so it works. Question number 3. Next, use your double number line to answer these questions. Okay, so how much flour should be used with 10 pints of flour, or of water? So when we look up there, we don't have 10 pints of water. What number could we possibly use to get up to 10 pints of water? Well, we know that 5 goes into 10, don't we? How many times does 5 go into 10? Twice. So if we double that ratio, we double 5 to 5, that would mean that we need 10 cups of flour. B. How much water should be used with 24 cups of flour? Again, we don't have 24 on there. Could we use one of these other numbers to figure that out? What other number can go into 24? Let's start at the biggest number, so that way maybe we can work backwards and find the simplest one. Does 5 go into 24 equally? No, it doesn't. What about 4? Will 4 go into 24 equally? Yeah, 4 times 6 is 24. So that means that we need to multiply it, don't we? How much water should be used with 24 cups of flour? 24. Because 4 times 6 is 24. Did anyone else just catch on that we actually have a 1-to-1 ratio? So every time that it's asking us how much water or how much flour that we need for X number, it's that same number because it's a 1-to-1 ratio. So with the pints of flour, on the first question here on A, it told us 10 pints of water. Did you notice that's 10 cups of flour? On B, 24 cups of flour is needing 24 pints of water. So how much flour per pint does this recipe use? Well, it uses 1 pint of flour, or not pint of flour, pint of water, per cup of flour. So again, it's 1-to-1 ratio. Okay, so let's stop and think about this. Do all increments on each line need to be equal? Yeah, they do. Because we're trying to compare one to the other. Do the tick marks on the top line need to match those with the bottom line? Why or why not? Yes. Because again, we're trying to keep the ratio equivalent to each other. If they're not perfectly lined up, then we're saying that they're not they're not equivalent. Does it matter what number we use to start each line? Why or why not? No, it doesn't matter which number, because if we find an equivalent ratio, we should be able to start with whichever number we want. Let's revisit the tuna casserole problem that we had. Okay, so the other day we looked at a recipe for tuna casserole that called for 10 ounces of cream of chicken soup for every 3 cups of elbow-shaped pasta. Alright, so for number 1, you're supposed to draw the double number line again. So if we look at number 2, if you made a large amount of tuna casserole by mixing 40 ounces of soup with 15 cups of pasta, would it taste the same? Well, I guess I need to go back to my double number line because I didn't finish it, did I? So I'm going to pause real quick. I'm going to go back and I'm going to finish it. So again, will mixing 40 ounces of soup with 15 cups of pasta taste the same as the original recipe? Well, if we look at 40 ounces of chicken, cream of chicken, look right below it, you have 12 cups of pasta. So would they taste the same? No, because 12 and 15 are not the same numbers. You would actually have more pasta than what you needed for that recipe. Question number 3. The original recipe called for 6 ounces of tuna for every 3 cups of pasta. We're supposed to add a line to our diagram to represent the amount of tuna in every different batch. Okay, so I added my line to represent the tuna. Question 4 wants to know, how many ounces of soup do we need to mix with 30 ounces of tuna? So we find our 30 ounces of tuna, which is right here. How many ounces of cream of chicken soup do we need? Well, if we look right below it, it's right there. So the answer to question 4 is 50 ounces. All right, so our lesson synthesis. What are some important things that you need to pay attention to when creating a double number line? We need to make sure that our lines are parallel to each other. We also need to make sure that each line is labeled about what it represents, which includes the units of measure. So if it's cups, make sure you tell me it's cups. If it's inches, make sure you tell me it's inches. And we also need to make sure that we spread our tick marks as evenly as possible. So if that means that you feel more comfortable getting a ruler and making sure that each one is a quarter of an inch apart, do so. So that way when we look at the top number line and the bottom number line, that they are lined up with each other so we can tell what number of this thing goes with what number of this thing. Now, do you think that you create a double number line diagram and correctly place and label the tick marks to represent equivalent ratios? Do you think you could tell me what the word per means? Hopefully the answer is yes to both of those. If you haven't already done so, please take your cool down.